right, so you guys had one thing you had to do in order to get your right answers last night. Today, not so fast. We're going to have to pay attention because we're going to do starting the process of understanding how to solve multi-step equations. So this is Chapter 2, Lesson 3. Solving multi-step equations. And I would recommend that we put this on the right side, and then the left side you will do your examples. So today's date is 11/4/15. So first I want to make sure we all are on the same page and understand what I mean by a multi-step equation. Highlight that in our yellow. And a multi-step equation is an equation that has more than one operation. So part of our chapter deals with just learning how to solve equations, and then the next part of it deals with reading and creating fractions. We're also going to review ratios and proportions, and we're also going to do some word problems, some of the first algebra word problems. We're going to deal with concepts of consecutive integers, evens, odds. We're going to talk about percent change problems. We're going to talk about distance problems. We're going to talk about mixture problems. So we got all sorts of stuff that we're going to be working with in this chapter. But first thing we have to know is how to solve an equation. And so the second part is how do you get the equation from the problem and then solving it. Okay. So today we're going to start off real simply on your multi-step equations. And on the ones that you get to do for homework tonight, predominantly all you're going to do is 2, maybe 3 steps to get to your answer. Then we're going to get a little bit more complicated, and we're going to throw back in the distributive property and what happens if variables are on both sides. So the equations are going to get more and more complicated in this chapter. Now, as far as we're taking a quiz Tuesday, it's going to be, again, different types of equations that we get to, and a little bit with word problems. Okay, so we're going to actually go through lesson 2-4, but we may need to do only half of it for the test. Okay, we'll have to see what goes on. Okay, so let's review the idea of order of operations. An order of operations became important to us when we had an expression where there was more than one operation, and we needed to follow the operations in a particular order. If we didn't follow in a particular order, then we were unable to, we would get the wrong answer. And a lot of you kind of found that out when we were doing our quizzes, that you guys were going out of order. Instead of multiplying first, you were subtracting first and completely changing what you were multiplying by. So, tell me what is the first thing we look for when we're doing order of operations. Okay, I'm going to call it grouping symbols because we've found out it's not always limited to parentheses. But that's kind of what we've been trained on. All right, what did I look for next? Exponents. All right, what did I get to do after that? Next would be multiplication or division, whichever came up as I was going from left to right. And then last would be addition or subtraction. Okay? So that's when I was given an equation, I was trying to get to an answer. But or given an expression. when I have equations, the answer is there in a sense because I have an equals and then usually a number. My job is to try to figure out one of the pieces, that variable, from the problem. So when we were doing the homework from last night and the night before, in order to solve, we would do the opposite to what we saw, or we did the inverse operation. So when we're going to solve multi-step equations, we're going to do the reverse of what we would do if we had the order of operations. So to solve multi-step equations, let's see how to say, we work backwards So what we're going to do by that, I'm saying that instead of ending with adding or subtracting, we're actually going to begin by adding or subtracting. Our goal is to get the variable alone. If the variable has a coefficient of any type, I don't want to get rid of that first. What I want to get rid of is the constant. So we're going to do addition or subtraction first. Now this is in general, because I'm going to give you an exception to this rule as one of our examples. So this I'm going to write down here is the constant. Okay? This is going to be the number that stands alone. It doesn't have a variable attached to it. Then I would do the multiplication or division. And this would be the coefficient. And the reason why we want to do it in this order is if I try to deal with the coefficient first, I tend to create a whole bunch of fractions, and that's not very good. All right, so what we're going to do now is move over to the example page. And our directions are going to say solve, check your solution, so we start with 11x minus 4 equals 29. So our first step is to get the number, the constant, and get it to disappear from the left. Okay? So what's the constant on the left side of this, the same side as the x is? What do you guys see? See a 4. But the 4 actually has a sign attached to it. What's that sign? A negative. So we're going to do the opposite of subtracting 4, which would be adding 4. And we do that to both sides. So we want to deal with the constant first. So again, remember, this is the addition property of equality. Okay? And when I do that, I get 11x. Negative 4 plus 4 is 0. So this is the inverse property of addition. And when I add 11 to 0, or 11x to 0, I get 11x. So basically how I got this answer is through the identity property of addition. So I'm not going to label these all the time, but remember what I talked about is that you guys are going to get questions maybe a little bit deeper on your Thurs work. So it may ask you what property allowed the 4 to disappear from the left side. Oh, that was the inverse property of addition. Okay, or whatever. So properties I'm going to keep asking you about because they're super important. All right. So on this side, I have 29, plus 4 is 33. So now I have 11x equals 33. So what am I going to do to get the x alone? Yeah. Yeah. The opposite of multiplying by 11 would be dividing by 11, which again would be the division property of equality. When I divide something by itself, I get 1. That's the inverse property of multiplication. The product of inverses is always 1 in multiplication. And then I get 1 times x is x. So that would be the identity property of multiplication. And then over here, we get 33 divided by 11 is 3. Okay? And then we can check our answer. So here's what I think is amazing, is in a very short period of time, I've used 6 properties. Okay? We just don't even think about what we're doing sometimes. So 11 times 3 is 33, and 33 take away 4 gives me 29, and 29 equals 29, which says, yep, x has to equal 3. Okay. I saw a hand over there. Was there a question?
No, I just answered.
Okay. So, are you expected on your homework to show me the properties? No. Okay. Are you expected to understand what property you've used? Yes. Okay. All right, so let's do another one. Oh. Whoa, where did that come from? That was weird.
The math you just did and put it on the notes.
That's weird. It's superimposed. Let's see how. I wonder what's going to happen with the video. So we'll have to check that one out. So I have negative 1/5 minus 4/9 a equals 2/5. Or 2/15, I'm sorry. So this problem kind of cropped up yesterday, and people were getting a little confused on their equations because they're looking at this going, oh, the math going on between the constant and the variable was subtraction, so I need to use addition to get rid of stuff. And it doesn't always work that way. The main thing you pay attention to is what's the sign on the constant. The sign of the constant is going to dictate what is the inverse math you're going to do. Okay? Now, let me show you something you can do, because this is another thing I see that people are struggling with. I can rewrite this equation as, that's terrible. Try that again. Negative 1/5, and then I can add the opposite. Okay? Both of these equations mean exactly the same thing. If you're getting confused about this sign, what happens to it when you deal with the constant, then rewrite it this way so that you'll understand that that sign, that negative, actually becomes a negative sign. That subtraction sign becomes a negative sign on the 4/9. I saw that happen on the test when you guys were combining like terms and you left the signs behind and completely got wrong answers when you did that. So this was not the quiz from before. So either way, what we're going to do is focus in on this guy right here. So how do I get rid of a negative 1/5 in an addition or subtraction problem? Well, I'm going to add it to both sides, because I want this to zero out, and it does. So that's why I'm always going to get a zeroed out pair, because I'm always going to do the adding or subtracting first. So what's left behind? Negative 4/9 a, and then equals, and then I have this problem over here, so I'm going to rewrite that. 2/15 plus 1/5. So now we have the complication of we can't do math with fractions unless their denominators match. So what's the common denominator for 15 and 5? 15. So notice I didn't have to change the 15 in the top fraction, so I'm not going to change his numerator, but the bottom fraction I had to multiply top and bottom by 3. So that gives me a positive 3. So now I have negative 4/9 a equals, and then 2 plus 3/15 is 5/15. Okay? Now, I got asked in first period, can I go ahead and simplify 5/15? And my answer is yes, but you don't need to do it on its own. You could wait and do it when we're doing the next step. My next problem is I want to get rid of the negative 4/9 times the a. So what do we say is the best way to solve that? If I do division, then I get this fraction and a fraction. And most people have no clue how to solve that. So, Vincent, what did we say to do instead? So what we're going to do is multiply by the reciprocal of negative 4/9, which would be negative 9/4. We're going to multiply both sides. So anytime we're contending with fractions as either a coefficient or a constant on the other side, instead of doing division, do multiplying by the reciprocal. So when I multiply by reciprocals, I get 1. So that's my inverse property of multiplication. And then I get 1 times a is a. That's my identity property of multiplication. And then over on this side, I'm going to see if there's anything that I can cancel. What do you guys see that I could cancel out? 9 and 15 share 3 in common, so 9 divided by 3 is 3, and 15 divided by 3 is 5. Anything else that I could cancel out? Brandon? Anything else I could cancel out? I see something. Olivia?
Well, I don't... 5 over 5 would equal 1.
Exactly. The rule is with canceling is it's any numerator to any denominator. So it could be within a single fraction, or it could be between a numerator of one fraction and the denominator of the other one. But yeah, definitely that cancels out. So what am I left with on top? Let's see, my signs are different, so my answer is going to be negative. 1 times 3 is 3. That's in the numerator. 1 times 4 is 4. And so my answer works out to be a equals negative 3/4. Okay, I got one more, and this one we're going to call the exception. Everybody good on this one? Andrew, you got it? Okay, Taylor, you good? Connor, you okay? Okay. So here comes Mr. Exception. If I could write. Money. So number 3 is going to be our exception problem. I have a plus 7 divided by 8 equals 5. So remember we said we're going to solve equations working backwards using the reverse of order of operations, and we would start with adding or subtracting. Do I have a standalone constant in this problem? No, I don't, because I've got a fraction on the left side. So actually that denominator 8 goes with the a and with the 7. Now I could separate it out and make it 2 pieces and deal with it that way, but then that's creating fractions for me. So I've got an easier way of solving this problem. What do you think I'm going to do to start this problem if I've just told you it's an exception and we can't start with adding or subtracting? What do you think our alternative is going to be on this one? Jacob? Yeah. What we're going to do is multiply both sides by 8. Now, what this looks like I'm going to do is distribute that 8. But then that defeats the whole purpose, because the reason why I want to multiply by the denominator up in the numerator so that these guys cancel each other out, leaving me with 1. I don't want to touch the a plus 7. I want it to stay as a plus 7. And on the other side, I get 40. So this exception makes this problem exceptionally easy, if I remember to use the exception. So again, I did multiplication property of equality, was multiplying by the 8. 8 divided by 8 is really the inverse property of multiplication. It says I'm going to get a product of 1. 1 times the quantity a plus 7 gives me a plus 7. That's my identity property of multiplication. Now what do I do to get a alone? Say again? Opposite of adding 7 is subtracting 7. So the exception comes when my original problem is a complete fraction on one side. Get rid of the denominator. Okay? All right. So let's see. I am going to give you a challenge question because you guys are so together with it. And let's see if you can answer this challenge question. I'm going to find a good one. Ah. Oh, I did this one. Let's do this one. I did that one already. We'll give you a different one. What if I give you this one? Negative 5 halves equals 3/4 z plus 1/2. Okay, first thing I notice is let's rewrite it with symmetric property. So we get 3/4 z plus 1/2 equals negative 5 halves. Okay, so that way. Now, we solved a problem, our second one, that was like this, and we did the opposite of adding 1/2. We subtracted 1/2, and then we multiplied by the reciprocal of 3/4. But my challenge is there a way that we can solve this problem without contending with fractions? Cameron, what do you think? Okay. How could I get the fractions to all just genie blink disappear? Desi, what do you think? Okay, that we have to be cautious with because what if my denominators were 3's? Then I'd get some repeating decimals. That would not work. Jacob?
Well, I don't have the answer, but it just helps me when I never solve the denominators are all even.
Okay.
And multiples of 2.
Okay. Actually, that does have something to do with it. Marlene? How? Julia? Okay. Now, does that cancel out fractions? Okay, so let's use Julia's idea and Jake's idea together. So they all have a common denominator, right? Because they all are even. So I could find one, and Julia said it's 4. So what would I do to get rid of a denominator of 4 if all I was looking at was 3/4 or 3/4 plus z? What would I do to get rid of the 4 as the denominator? Yeah. So what we could do is, since 4 is the least common denominator, why don't you try to multiply by the LCD? In this case, it was a 4. So if we multiplied each of these by 4, look at how much easier this problem becomes. So the 4's cancel, leaving me with a 3z. 2 goes into 4 twice. 1 times 2 is 2. 2 goes into 4 twice. Negative 5 times 2 equals negative 10. Do you have to use that strategy? No. Does it make the math solving easier? Yes. Okay. So to solve it, we start with the adding or subtracting. The opposite of adding 2 is subtracting 2. We have 3z equals negative 12. Then the opposite, of multiplying by 3 is dividing by 3. We do that to both sides. And we get z equals negative 4. As long as we treat every term in an equation the same exact way, that multiplication property of equality says you are not changing the outcome. Okay? So that's just a suggestion, something to try. So I guess the super duper challenge would be Could you think of something similar to this idea if you had a decimal problem? And I'm not going to ask for answers now. I want you to think about that and see if you can come up with that and tell me about it tomorrow. So like example on question 47 that you have tonight, or question 43, what could you do to first make the decimals all go away to make the math simpler? Okay?